TV on or off?
Off.
Off. And let's turn it on. So first I will leave a message for Gao, saying I'm very sad you're not here. I hope you're having a nice time in Turkey and you're thinking about us. Right, let's get started. So
what's the difference in Turkey and Turkey?
Difference between what?
Turkey and Turkey.
No difference, same word.
Same word.
Yeah.
Sudan, please.
Yeah. Yeah. Now, the next question is, which was first? Turkey the bird or Turkey the place? No, Turkey the place.
Yeah.
Right, DIFC, workbook, physics, atoms, and graphs. I ordered some more RAM memory. I should get it. No, I should get it maybe tomorrow, maybe Wednesday.
How many?
But this is 1 gigabyte, so I got another gigabyte
Two.
because
Why? you just use it in.
make it a little faster.
Okay.
2 gigabytes
Yeah.
is the maximum.
It's max.
Is maximum, yes. You can't have more than 2. It's maximum.
Okay.
So I want it to be maximum. Also, I got a new battery.
Why? Your battery is destroyed or?
Remember my old battery? It's very bad.
Oh.
Now I have a new battery. Let's see.
New battery, you can use it 2 hours or 3 hours.
Let's see. Let's see what's.
No, it don't have time.
Hold on, I got the time.
No.
There, look. No, not time. Sorry. I think like 3 hours. Right. Graph of log A and log N. Got that? Where's your paper, Ben?
I remember I bought this computers. In the beginning, it's just four
Gigabytes.
Yeah, gigabytes, and I buy two pieces of the gigabytes.
Good.
So this time it's 8.
Good.
Yeah,
Nice.
it's very nice.
I will soon have 2. Okay, graphs of log N and log N. Alright, so below we see N is decreasing. Now I think we've seen graphs like this. So I don't think I'll bother you drawing it nicely because I think we did graphs like this already. Just roughly, you know what the graph looks like. If you were to graph it, what shape does it make? Yeah, that's it. It goes. Whoops. Yeah, there we go. Here is time in seconds, and here is N in moles. And let's say here's 100, and we'll say 2, 4, 6, 8, 10. Okay? If you were to graph this, it would look like this. Yeah. Do we remember the name of this graph? Mm-mm. The name of this graph. No. Can you remember its name? In maths?
How?
Ooh, good guess. No. Begins with an E, Ben.
Ah. Dx. What?
No? Don't remember?
Like
Exponential.
Oh, it's not plot.
Exponential
Okay.
is the name of this shape. Remember?
I don't know.
Okay. But you did it in maths class with Joan. Anyways, next what I want to do,
Become linear.
yeah, to make it become linear. So, in physics, we don't like these graphs. We don't like these in physics. What type of graphs do we like in physics? You said it, Ben. What type of graphs do we like in physics? We like linear graphs, don't we? So the way we can make it linear is by taking the log of n. So what I've done in this table is I have n, and underneath I have log n. And then I'm going to draw this. Instead of n, we'll plot log n. Okay? I would like you to try and plot that for me. You don't have to be very neat. A little neat. Try to plot this one, please. Draw this one. So you start at 4.61 and then goes straight down. You still have crisps.
Yeah.
How many bags did you buy?
3.
Only 3, not 20.
3 big.
Oh, 3 big bags. So in total, 60?
Yeah, 56. Oh, 4. 54.
54.
This is the last.
54 bags of crisps, wow.
Crazy.
Pretty crazy. Okay. You drew that? Yeah?
Yeah.
Okay, well, so I only want a rough drawing. So, if you drew this, you'll notice that the graph is linear. Straight line. Oh, that's beautiful, Summer. Nice straight line. So, why is it a straight line? Well, what I'm about to do, you need to know for the exam. Okay? So, this is something they could ask you to prove in the exam. So, please write this down carefully. It's a proof. Ugh. So, I think this proof is not so difficult because you do something like this in maths class. You start off by saying n equals n0 e minus lambda t. You put log here and log here. Then you put the first rule of logs, log n0 plus log e minus lambda t. Just multiply. So, yeah. Log n equals log n 0 minus lambda t log e. Well, log e is 1. So, it's log n equals log n 0 minus lambda t. So you have log n equals minus lambda t plus log n 0. Now, when you make the graph, what you're doing is you're putting this on the y and this time goes on the x. So if you compare that to this, can you see then it means your graph is linear and also the m is minus lambda. So on that graph, let's see, let's put it here. If you were to graph this time and log n, you get a graph that goes like this. The lambda is equal to minus m. That's useful. It's useful and it's important. Okay, so you need this proof for the exam. You all have this proof written down? Yes? Okay. You need, so this you need for the exam. They sometimes ask you for this proof. So there's an extra little piece. This m equals minus lambda is also true if you plot log a. So you can use a or m. If you were to replace this with a equals a0 e minus lambda t, you get the same result here for the m. Because the only difference is here and here. So the only difference is here and here. So the lambda is still minus m. It doesn't matter if it's log a. Is that okay? Yeah. So, if we linearize, then we get the result I just proved. M equals minus lambda. And it's also true for A. Okay, are we happy with that? Yeah. Right. Let's see. I have two examples. So let's have a look at the first one. Okay. So we have activity, we have time, we have activity in mole becquerels. First, graph it. Okay, so before I graph it, what do I need to do first?
Log.
I need the log, yeah. So let's get, let's open up our Office program. Oh, come on. Right. Office, Excel. Oops. Okay, well, while I'm waiting, why don't you copy the numbers down, the table, then we'll get the log. somewhere? Yeah. Okay. Sure. $54 packets of crisps. Amazing. How long will it take you to eat them?
I don't know.
1 week? 2 weeks?
How long?
A month. Okay. Right. Let's write down these numbers. So, time in seconds. How much time is there?
12.
Okay. And then activity in mole BQ. What's the first one?
10.
10.
Yeah.
Okay, 10.0, yeah. And the next one?
8.4.
Okay.
7.07. 5.95. 5. 4.2. 3.54. 2.97. 2.5. 2.10. 1.77.
Like this?
Yeah.
Okay, so what I need to do is I need to get log of the activity. So I'll just type in ln of that. And in the exam, we should do 4. No, sorry, we'll say 3 for this.
So in the exam, we can use computer.
You can use your calculator. Okay, let's plot. Insert, chart, chart. Does anyone remember the name of the graph? What is it called? You did this in your lab report. What graph do I pick? Ah, come on.
The
Scatter, yeah.
Yeah.
Okay, so this is activity against time. And the x-axis is time in seconds. The y-axis is activity, no, sorry, it's log activity in log moles BQ. Okay. And I want to show the, there we go. Nice. Okay. So this is what the graph looks like. So the first question is to graph it. We've done that. From your graph, estimate lambda. So what do we need to, what do we need to calculate from the graph to get lambda? The m. Okay. I want everybody to look at this graph, pick 2 points on it, and calculate the m. Pick any 2 points. They should be far apart.
Just roughly.
Roughly, please, yeah.
So, 1.9?
1.9?
2.
2.25.
No, I mean
Oh,
the second one, the third one.
yeah, okay, 1.9. 0.6. Yeah?
0.16.
Let's see how good you are, Ben. Not too bad. 0.17. But there's a small problem. Okay? The small problem is this. The units are not BQ. They're mole BQ. So then the question is, do we have to do anything to this answer? So, for example, you said, Ben, that m equals minus 0.16. So let's just say 17. Okay? So that means that lambda equals 0.17. But my question is the unit still per second? What's wrong, Silver?
No.
No? What do we think? Is it still per seconds or not? Because if you look at the graph, we have moles here. Well, let's see. Let's see. So, when we look at the graph, you took 2 points. The first point here was t1 log a1. Yeah? And here was t2 log a2. And so, really, I want to know, is this per second means is this guy seconds? But, no, sorry. Is this guy also per seconds? Well, let's see. So the m here is log a2 minus log a1 over t2 minus t1. That's equal to log a2 over log a1 over t2 minus t1. Now, this is seconds and this is seconds, so the total here is still seconds. This is mole BQ and this is mole BQ, so what unit is here?
Not BQ.
No? No?
1.
Yeah, so what unit is that? No unit.
I say 1.
Yeah, really no unit. You know this. You know, if I have like 2 pascals over 4 pascals, the answer is 0.5. Don't tell me you forgot this. Okay. Are you sure? Because these cancel. So this is still per second. Okay? So still per second. Yes? Are you sure? Okay, fine. So,
we write that down?
do you think you'll remember it?
Maybe.
Okay, what you could write down, if you have this graph, this could be log n, log a, whatever, and this is time, and this time has a unit. The unit for m will be the same as this unit, but just with a -1. So if you're the great thing about log is you don't care about the units. The units aren't important here. It only matters for the m what the unit is for in the x. Okay. So in log graphs, only the x units really matter. The y units aren't important for log graphs. Happy with that?
Really matter.
Yeah?
means
Important.
Yeah, it's like important. Truly important.
okay.
You know what I mean? Truly important?
No.
What else could we say instead of truly important? Really matters means it's important. Really, truly, deeply important. Yeah? Alright. Next now. What's the half-life here? You could see it from this table. Very good. No, not quite. 4.
4.
Yeah, 4. Yeah. You were looking at
Then
this. Yeah, 4 seconds. But remember, you also have this formula. T equals log 2 over lambda. So what did we say lambda was? 0.17?
Yes.
Right, so roughly what's this? Can you, Summer, could you type it in?
4.07. 4.08.
Okay. It's okay. Right. What is N0?
2.3.
Maybe. I have to calculate. N0 equals A. Sorry.
No,
Lambda.
It's log and 0.
Yeah.
Log and 0 is 2.3.
A equals minus lambda n. What was the A? The A was 10.
And, yeah.
But be careful, it's not 10, it's 10 times 6.02 times 10 to the 23. And that's equal to 0.17. Yeah. So, well, no, it's okay. What you can do is just divide by 0.17 in the 10, and we'll just say the answer is moles. So 10 divided by 0.17, what's that, 60 or something?
Fif- 58.8.
Eight. Moles. Okay. What is n when t is 11? Alright, well we know this. We can say n equals n0 e minus lambda t. So that's 58.8 e minus 0.17 times 11 moles. We're using moles. Okay, what's the answer here, please? Yeah, 11.
9.06.
Moles.
The NO
N0, yeah?
N0 equal this.
Oh, this is n after 11 seconds.
So
Yeah, N0 is, 58.8 moles.
I mean the above.
Up?
Yeah.
Yeah.
The 6.02
Yeah,
and that's 23.
yeah.
In
That's a mole.
pencil or more?
Yeah, I just gave the answer using moles. So
Oh,
I just wrote that as mole.
so
You can use moles. Yeah. It's okay.
where's the 10?
Which 10? This 10?
Mm.
10 over 0.17 is 58.8.
I know where 10 come from.
Ah! here.
Okay.
It's okay? Continue? Why did I do this? It's the same question. I just changed it from moles to mega. But I kept everything the same, so it's kind of pointless. I don't know why I did that. Why did I do that? I don't know why I did that. I don't know why I did that. It's the same question. Alright, so in the exam, you don't have a computer. So what paper must you use? You must use graph paper. Draw a nice, neat graph. Yeah. Now, I want you to be careful about something. If I delete this word, if I just said graph this, do you or do you not use log? If I just said graph this, no log. But if I said graph this in an appropriate manner, then you use log. What is the meaning of appropriate manner?
Do you know?
Maybe, mostly, not quite. What's the meaning of appropriate manner? Yeah, very good, yeah. Graph this in a good way. In a physics way, exactly. In a good physics way. Exactly right. Good job. Okay. So it's not so difficult today. What did I give you to do? I gave you one graph, two graphs? I only gave you one graph. So, look, I just want you to do question 1. You don't have to bother with question 2. Silly. So because there's only one question, because there's only one question, I want you to make a beautiful graph. Okay? Really, a beautiful graph. The best graph you've ever made. And then we'll go on to the next lesson.
I just need two points and.
No. Draw me a beautiful graph. Thank you. No, Ben. Not in this. In this. Summer, do you have a ruler?
I have a book.
How can you draw a beautiful graph with no ruler?
Link out of thing.
Okay, I believe you.